Hi friends, so now we are going to see one new project, so that is automatic fire detector and extinguisher. It means it detects the fire whenever there is a fire using one temperature sensor, and after detection of fire it is going to pour some water on fire. So this is the our project aim. So it should be detect the fire, and automatically after detection motor should be or water pump should be on, so that we can pour some water on fire, right? So this is the circuit diagram of fire detector. In this we have used components like potentiometer, so that is 10 kilo ohms value, so this is the potentiometer. And second one, thermistor, so NTC 10 kilo ohms thermistor. NTC means negative temperature coefficient, so I will explain later about the component. So third one is resistor 10 kilo ohms, so this is the 10 kilo ohms resistance. So next, comparator or app amp, number is LM358 comparator. So this is the LM358 comparator. So next component is BC547 transistor. Sixth component, relay, which is 5 volts operating relay. And seventh component, water pump, to pour water on fire, so water pump. Eighth one, voltage sources and connecting wires. So one breadboard. All these are the components, right? So coming to circuit explanation. So before going to the circuit explanation, we will see thermistor and comparator. Okay. So this is the thermistor. Right. So this is the thermistor symbol. So thermistor. So we have two types of thermistor. So that is PTC and NTC. So PTC means positive temperature coefficient. Right? If temperature increases in PTC, if temperature increases, resistance also increases. So resistance is increasing with the temperature. In NTC, negative temperature coefficient means if the temperature increases, resistance will be decreases. If the temperature decreases, resistance will be increases. So this is the principle of thermistors. So here in our project we are using NTC, negative temperature coefficient. So that is 10 kilo ohms means 103. So 103 negative temperature coefficient means, so we have two conditions, temperature and resistance. Here two condition, temperature we are taking and resistance of the NTC. If temperature is increased, if the temperature increased, resistance of the NTC will be decreased. So this is the relation between temperature and resistance of negative temperature coefficient. So if the temperature increases, resistance will be decreases. If the temperature decreases, resistance will be increased. So this is the first condition and this is the second condition, right? Temperature increases, if the temperature increases, resistance decreases. If the temperature decreases, resistance will be increases. So this principle here we are using for the to detect the fire. Okay. So here we are using thermistor as a temperature sensor. Next component is comparator. So this is the comparator, LM358 comparator, LM358 comparator. So it has two inputs. LM356 has two inputs. So pin number 3 and pin number 2. So pin number 2 is inverting input and pin number 3 is non-inverting input. For comparator we have two conditions. So first condition is if voltage at pin 3 is greater than voltage at pin 2. So output will be high. So that is 1. So second condition is voltage at pin 2 is greater than voltage at pin 3. So output will be 0. So this condition we are using for the in our application. So coming to circuit diagram explanation. First LM358 comparator. It has 8 terminals. So it looks like physically like this 1, 2, 3, 4, 5, 6, 7, 8 like this it looks like. So first terminal is output terminal. Here we have used one transistor for switching action, and pin number 3 is connected to the second terminal of the thermistor. So this is the first terminal of the thermistor and this is the second terminal of the thermistor, and pin number 3 also connected to the ground through 10 kilo ohms resistance. Next, pin number 2, so this is the inverting input. This is connected to the VCC through one potentiometer. Indirectly we are giving some voltage through potentiometer to the pin number 2. Why sir? So this is acting as a reference voltage. So this is the V2 is the reference voltage, V reference. So this is the V reference. Comparator compares pin number 3 voltage with reference voltage. So that is V3 compares V3 and V2. And this is the 10 kilo ohm resistance. Next, transistor and one relay coil. So this is the 5 volts relay coil. To switch on high load application or AC loads, I am using one relay coil. And so this is the water pump. To switch on or switch off the water pump, I am using one voltage source. So this is the components. So first explanation. So coming to explanation. So first condition, temperature is high. So temperature is high. If the temperature is high or temperature is increased in industries, so temperature is increased means resistance will be decreased. Temperature increased and resistance is decreased. So this is the thermistor. If the temperature is increased, resistance of the thermistor will be decreased. So if the resistance is low condition, whenever there is a low resistance path, this VCC will flow. So this VCC will flow like this. And here we have resistance. Voltage will be developed across. Due to this resistance, voltage will be developed at this node. So this node is V3, right? So this is the V3, and second terminal already connected to the VCC. So this is the second pin of the comparator. So this is the V2. So due to low resistance path, we are getting some amount here, some voltage will be developed. So this voltage is greater than the pin number 2 reference voltage. So this is the V reference. So V3 is greater than the V2. So at this condition, it will produce 1, means high voltage. Okay. So this high voltage is going to applying for the base of the transistor. So this is the base of the transistor. So here connected to the VCC through relay coil, and emitter connected to the ground. So remaining connection is base. So whenever there is a temperature is high, resistance will be decreased due to low resistance path, and this comparator comparing two inputs and producing output as 1. So this output is going to fed for the input of the means base of the transistor. So due to that, at this condition, this transistor will be turned on and this VCC will flow like this. So due to current flow, this relay will be turned on. So turn on, and what is meant by turn on? So if the relay will be turned on condition, means this coil is producing some magnetic flux. So due to magnetic field, this pole is attracting towards the normally open. So this is the normally open from this side to this side. So here at this condition, this is the closed circuit. Okay. So this is the closed circuit. So that is why this pump will be in on condition. So then we will get water. So, due to pouring of water on fire, temperature will be decreased, right? Temperature will be decreases. So, due to low temperature, resistance will be high condition. So, this is the next one is second condition. So, temperature is low and due to temperature low, resistance will be high, right? So, resistance high means, so this is the open circuit. So, there is no current flow from the this terminal. So, hence there is no voltage at V3. So, that is why here in this condition voltage at V2 is greater than the voltage at V3. So, at this condition comparator will generate 0 volts. So, that is why here we have second condition, that is 0 volts. So, that transistor will be in off condition. So, off means, so this is the open circuit. So, now 0 volts. So, transistor will be off condition. So, hence this pole will be returned back to the normally closed. So, hence pole connected here, this is the open circuit. Now, it is open circuit. So, it look like this. So, battery is connecting and there is no closed circuit, it is a open circuit because it is not connected. Okay. Hence, this water pump will be in off condition, there is no water on fire. So, these are the two cases, one is temperature is high condition and second case is temperature is low condition. If the temperature is high, resistance will be decreases. Due to resistance decrement, we are getting some here voltage will be developed. So, this voltage is comparing with the V reference voltage. So, whenever the V3 is greater than the V2, amp is producing the output. So, due to that output, relay is on condition and motor also in on condition. So, after some time, so we are pouring some water on the fire. So, after some time temperature will be decreased, so temperature will be decreased and resistance will be increased. So, due to increment in resistance, there is no flow from the current in this path, so that there is no voltage. At this condition, this V2 is greater than the V3. So, that is why it is giving output as 0 volts. So, at this condition, relay will be switched back to the normally closed. So, that water pump will be in off condition. So, this is the working principle of automatic fire detector and extinguisher. So, next we will go for the practical connection of this project. So, in this we have used all the components. So, I will show all the components one by one. So, first one is potentiometer. So, this is the potentiometer. It is 10 kilo ohms potentiometer. You can find on top of the potentiometer. So, this is the 10 kilo ohms potentiometer and it contains 3 terminals, first one, second one, third one. So, this is the first one, second one and third one, right. So, next is thermistor. So, thermistor looks like in black color and it has 2 terminals. So, this is the thermistor and which offers 10 kilo ohms resistance. It has 2 terminals like this. So, first terminal VCC, red terminal connected to the VCC and second terminal connected to the pin number 3. So, next component is 10 kilo ohms or 15 kilo ohms. So, you can use 10 kilo ohms. This is the 10 kilo ohms resistor. And next component, operational amplifier LM358. So, this is the LM358 comparator. So, it has 8 terminals. So, this is the first terminal, second terminal, third terminal, 4, 5, 6, 7, 8. So, all these are the 8 terminals. So, next component is BC547 transistor. So, this is the BC547 transistor. Okay. So, it has 3 terminals, first one is collector, middle one is base and third one is emitter. So, if you face this flat surface to opposite to your face. So, this is the collector and base, emitter. Next component is a relay coil. So, relay coil has how many terminals? 5. It has 5 terminals. So, this is the relay coil. So, I connected connecting wires. These two, one and blue color, are the coil connections, these two connections, right. So, this common, so this is the common terminal and middle one is common. and normally open terminal is blue color, so which is normally open. So this is the relay coil. And next connection, next component is water pump. This is the water pump, DC 9 volts water pump, and it accepts the water from here and loads water from this point. So this is the water pump, it has two terminals. Now next, last one is breadboard. So this is my breadboard, so I can use breadboard for the to give the connections. So this is my breadboard and patch cards or connecting wires to give connections between the all components. So after taking all components, we go for the step by step connections. So place operational amplifier, so like this. Okay, so this is the breadboard connection. So after placement of comparator, so complete input connections, that is pin number 2 and pin number 3. So this is the potentiometer connection, and next input is thermistor. So these are the input connections: 10 kilo ohm resistor, thermistor and potentiometer. So next, biasing. So 8th pin VCC and 4th pin grounded. So next, output connections from pin number 1 to base of transistor. Next one, relay coil. So these two terminals are the relay coil terminals. First one is the VCC and collector terminal, these two. Next, water pump. This is the water pump, and for the water pump I am giving connections. Okay, so this is the water pump. So this is the water pump. So you can find here, this is pump motor and connected to the VCC, and next end connected to the common terminal and normally open connected to the ground. So this is the water pump connection. So remaining connections are emitter. So emitter should be grounded. So this one is emitter and ground. This is complete connections. Next, biasing. Voltage source, so connect positive and here ground terminal. So these are the final connections. If there is an increment in temperature, so I am going to increment the temperature. So here water pump is in on condition. So it automatically off. So again, if there is a temperature, it is water pump is on. So this is automatic fire detector circuit. So you can find final connections here. So this is the water pump. I dipped into the water, and these are the poured water. Right. All these are the final connections. So thank you for watching.